Good morning, guys, and afternoon. Miss Newkirk doesn't feel hot today, so I'm going to record this lesson so that I don't have to repeat it 6 times today. So, what makes a world habitable? All right, the requirements for life. So, every living thing has the same basic needs to survive on Earth. You need water. You need a moderate temperature, not too cold, not too hot. You need oxygen to breathe in, nutrients, an atmosphere, and energy. Water. Every living thing must have water. We can live up to 30 days without food, and we can live up only for 3 days without water. That's crazy. Water, 3 days. Earth is the only planet with surface water. Mars has surface water and still has ice in it, polar ice caps. Mars and some moons have deposits of underground ice, which might melt to produce water. In Europa, Jupiter's moon has a vast ocean beneath its outer shell of ice. But they are too cold, and we'll talk about why they're too cold, and the ice cannot melt unless melted by humans. All right, moderate temperature. Earth's proximity, which means the distance from the sun, determines its temperature. Life is limited to its temperature range of about 15 to 115 degrees Celsius. Proteins and genetic material begin to break down at temperatures above this limit. Chemicals in living cells react slowly in temperatures below its limit. So moderate temperature just means that it's like a good, comfortable temperature. Okay, it's not too cold, not too hot. The Earth's atmosphere. Earth's atmosphere is 70% nitrogen and 21% oxygen. The atmosphere is held in place by gravity. It insulates the planet. That means it protects, holds it all together. It protects it from meteorites, impacts. Those are the flying balls that are in space that are rock, all right? And it protects from harmful radiation. So we talk about UV rays. Whoops, I wrote an R. UVA rays. That's why we wear sunscreen. All right, and then it protects chemicals needed for life, such as nitrogen and oxygen. It protects it and keeps it in. Energy is light energy from the sun or chemical energy needed for the process of light. So light energy from the sun or chemical, remember that's what plants use, is the chemical energy from the sun. And the sun provides the energy needed for plant growth. That's what I just talked about, photosynthesis. It turns it into glucose. When there is too little sunlight or too few chemicals that provide energy to cells, organisms die. So we need just the right amount of sunlight. The inner planets get too much sunlight for life, and the outer planets get too cold. So we have 8 planets, right? We have the sun, and then as the planets go out, Earth is the 4th planet. And so we're in that perfect zone. We're not too cold and not too hot. Nutrients. Nutrients are chemicals needed to make proteins and carbohydrates for growth. These nutrients are cycled in the earth. They're cycled in the earth. So planets without systems to deliver nutrients to organisms, example, the water cycle, excuse me, or volcanic activity, they cannot support life without those nutrients, without the lichen, okay? So we have to have those nutrients. When nutrients are spread so thin, they are hard to obtain, such as on a gas planet, the life cannot exist because there's too much gas. Accommodations for manned space exploration. The first human being to travel into space was Yuri Gagarin in 1961, followed by a month later by the U.S. astronaut Alan Shepard. All right, remember that this picture is a great picture to talk about this, that we have to have a spacesuit to go into space, and we have to have our own atmosphere because there is no oxygen on the moon. So we have to be in space, and so we have to make our own atmosphere to hold the air in. It's needed for oxygen. All right, challenges in living in space. Like I said, there's no oxygen. There's no air pressure. There's no water. There's very low gravity, which means microgravity. Can sound travel? No. Okay. I don't know if I can show you this video. It doesn't look like it. I'll show it to you in class after we finish. It's pretty cool. So after your video notes. Yeah. All right. So the spacesuits provides oxygen. It helps maintain air pressure. It protects us from the radiation from the sun. It protects us from extreme temperatures, so if it's too cold or too hot. And it also protects us from the impacts of space dust that's all floating around, because remember, there's no gravity. So if you have dust off of a planet, it just goes into the air and floats, because there's no gravity in space that holds it all down together. I believe. I think that's how that works. Microgravity is because of microgravity, the muscles can atrophy when not used for long periods of time. This means just to wilt away. All right, and bones lose calcium. That calcium is what holds your bones together. And so we have a video of daily exercise of how they exercise on the space station. And I'll show you that at the end of class. Other issues, so we have psychological issues, so stress and anxiety, depression, insomnia. So those are things that can happen to us when we were in space for long periods of time, because it's not like they go to space for a week and then come back. They stay for months upon months in space. So these are some questions that we'll just review when we conclude this video, when everybody's done. And so just take a moment, read over them, and see if you can come up, like maybe put some stars in your notes of where you might have find these answers. All right. Thank you guys for being awesome. I'm sorry Miss McWhorter doesn't feel good today, but we have other stuff to finish after we take our notes as well. So once you're done, log off and put your notes in your journal.